Have you ever wondered how a website can go from being a tiny side project one day to a global sensation the next without completely crashing and burning? Well, today we're going to pull back the curtain on web scalability. It's the incredible and often invisible engineering that keeps your favorite sites online even when millions of us are all clicking at the exact same time. So, to get us started, let me ask you a question. Imagine you've built a website, you finally launch it. What is the absolute best problem you could possibly have on day one? You got it. Too much success. I mean, you've gone viral. Your link is trending everywhere, a big news site picked you up, and suddenly the entire world wants to see what you've built. It is literally the dream. But here's the paradox, the kind of funny thing about all this. What's also the worst possible problem a website can have? Yep, exactly. That same tidal wave of traffic that means you've made it, that can also be the very thing that completely overwhelms your server and knocks your entire site offline right at your big moment. It's what you want, for sure, but man, it is a huge technical problem. So your site's a hit, your single server is chugging along, barely keeping its head above water. This brings you to a major fork in the road, the first really big decision you have to make when your website starts to grow. Okay, so let's break this down. You have two main choices. On one hand, there's scaling up. This is the simple route. You just buy a bigger, badder, faster server, more horsepower. The problem, it gets crazy expensive fast, and eventually you just can't buy a bigger machine. You hit a hard physical limit. On the other hand, you can scale out. This means instead of one giant server, you get a whole bunch of cheaper, standard servers and have them work together. It's a little more complex to set up, but it's way more cost-effective, and you can just keep adding more servers. You can scale almost forever. For any site that's really blowing up, scaling out is pretty much always the right answer. But okay, you've made your choice. You're scaling out. Now you have a whole new headache. You've got this entire fleet of servers just waiting to help. So when a new visitor shows up, where do you send them? How do you make sure you spread the work around so no single server gets buried? The answer is a really cool piece of technology called a load balancer. And honestly, the best way to think of it is as a digital traffic cop. It sits right at the front door of your website, and its only job is to greet every visitor and immediately point them to the server that's the least busy at that exact second. It keeps everything moving and makes sure no one server gets totally swamped. Awesome. Problem solved, right? We're balancing the load, everything is great. Well, not quite. See, in the world of system design, when you fix one problem, you almost always create a new weird one somewhere else. And in this case, our brilliant load balancer has just given our website amnesia. Let me walk you through what I mean. Let's say you go to an online store. You show up, and the load balancer sends you to server A. Perfect. You log in, you browse around, you find a book you want, and you add it to your shopping cart. All of that information, your login, your cart, it's all being remembered by server A. Then you click Checkout. The load balancer, doing its job, sees that server B is a little less busy now, so it helpfully sends your request over there. And poof, your cart is empty. Server B has no clue who you are. It has no idea you logged in or that you added a book to your cart because all of that info is stuck back on server A's memory. You see, each server is its own little island. And for any website that needs to remember who you are from one page to the next, which is pretty much every website, this is a total disaster. So how in the world do we fix this? We need to figure out a way to give all of our servers a shared brain, some kind of central memory, so they can all access the same user information no matter where the load balancer happens to send you. There are two main ways to do this. The first is called sticky sessions. It's kind of a quick fix where the load balancer just makes sure you always go back to the same server for your whole visit. It's simple, but it kind of defeats the purpose of balancing the load, right? The much better, more professional solution is shared storage. This is where you set up a central database just for session information, and all the web servers read and write from it. That way, it doesn't matter which server you land on, your shopping cart is always there. Okay, we've done it. We solved the amnesia problem with our new shared database. But I think you can see the pattern here. By creating a central solution, we have just introduced what you might call the final boss of scalability, the single point of failure. Think about it. We've created this one central place for all of our really important user data. Every single one of our web servers now depends on this one database to function. So what happens if that one database crashes? The entire website goes dark. It doesn't matter if you have 500 web servers running perfectly. If the one database they all need to talk to goes down, your site is offline. What was the point of all that brilliant scaling work if one little component can bring the whole thing crashing down? The only way to beat this final boss is with a concept called redundancy and replication. And it's actually a pretty simple idea. You just have multiple identical copies of every single critical part of your system. That way, if one of them fails, another one is right there ready to take its place instantly. No single part is essential anymore. And this idea gets applied everywhere. You don't have one load balancer, you have several. You obviously have hundreds of web servers. And you don't just have one database, you have multiple databases that are all constantly syncing with each other. The really big sites, think Google, Amazon, Netflix, they take this to the absolute extreme. They have entire copies of their systems in different physical data centers in different cities, just so a power outage in one state won't take them offline. And that really brings us to the core philosophy here. In a truly scalable system, any single component can fail, and the user, you and me, we never even notice. The website just keeps working. Netflix actually has this famous tool called Chaos Monkey that they unleash on their own systems. It literally just runs around randomly shutting down their servers, just to prove that their system is so resilient that it doesn't matter. No matter what fails, Netflix stays on. So the next time you're scrolling through your favorite app or shopping online, just take a second to think about the incredible invisible dance of technology happening behind the scenes. Is that site built on a fragile house of cards, just one server failure away from disappearing? Or is it a truly resilient, scalable network built to handle just about anything? It's pretty amazing when you think about it.